Hey, it's James from Finney Electrical. On today's video, we're doing some fault finding. So we're going to figure out why the lighting's tripping on this property. Let's get into this. Right, so we're on the job now then. So, customers let me limit the ladders. I know the double insulated ladders. So it looks like Sparky's done the board and got confused with what's going on. So they've banged it on a 32 amp, so I think something was tripping out. Some lights are not working. So what we're going to do is get the lid off. We'll assess what's going on. We'll talk you through how to fault find on something like this. So from what I can gather then, this is the board that's gone in. So it looks like they've banged all the lights on one. So when you do these fuse board changeovers, essentially these are RCBOs. So you've got a line of neutral going into the circuit and back. You've got RCD protection on that. If that RCD doesn't measure the same current coming out as it comes back, it's something called an imbalance and it'll trip. So anything more than 30 milliamps for this. If you look here, it says 30 milliamps. I know you can't see because it's dark in here, but trust me, it says 30 milliamps there. Yeah, it'll trip if it's greater than that. So obviously if you got like 1 amp even, which is way more than 30 milliamp, going to a light and it comes back down a different neutral, it's going to trip in it. So we've got multiple lighting circuits here. So we've got multiple lines, multiple neutrals. We need to figure out what's doing which, and then we can split them then, and then it's not all the lights on one. So there's that, and then it looks like there's a fault on the sockets. Looking at this then, so we've got a ring on there, so we'll check it is a ring, and then we'll do some fault finding and see what's going on, see? So first things first then, so I always do insulation resistance and testing line and earth, neutral and earth. So we're going to do that first for the sockets anyway. Obviously this is, if we turn on all the lights and it doesn't trip, we can assume there's no earth fault, but again, we'll test everything out, because there could be multiple faults here, and knowing my luck, we'll fix this and get it all up and running, and there'll be a fault on this one, and then we'll look bad. Oh, this light's not working, this socket's not working after you've been. But yeah, if we can test it all and say everything's perfect and everything works, then we can confidently say when I was there everything was working perfectly, and here's the picture of the results. I'm just bobbing around then, just flicking on lights, just making sure everything's on in the on position, and then when we pull it all out we've got resistances we can actually measure to. So if we do continuity or even insulation resistance between line and line of another cable and the lighting cable, a neutral, and the greater than 2 mega ohm or whatever, or greater than a meg, then we can safely say that them two cables are not connected, and then they can go in the separate breakers. But somewhere there's a borrowed neutral, so right, so we've got one switch for one switch for another. It's a bit different, isn't it? So yeah, let's get all these on then, all the lights on, and then we can start separating those lighting circuits, and we can figure out what's doing what. That'd be nice. House is never ended, like a 8-bed. Right, so what are the elements to the circuit? Obviously we've got the RCBO, so MCB/RCD. So you got that, you got the cable in itself, you got the fixtures attached to it if it's lighting. I'm going to say accessories then, but that's sockets, isn't it? And that's about it. So we've basically got to test each individual point to make sure everything works. So you don't just test the cable, and you've got to test the breakers as well. So what we'll have to do then, we'll do an RCD test just to make sure these are working, so we'll do that first. Obviously that'll need swapping out for a 32 RCBO, and then what we'll do is dive into this lighting. We'll see which one of these have shared neutrals, and then what we'll do is pull them separate. So if you've got three, like we've got 1, 2, 3, 4, we've got six cables there. So what I have to do is just pop like a little fly lead to a Wago to do the lines, fly lead to the neutral to do the neutrals. And the ones that are tied together will pop in one breaker, and then all the ones that are separate to each other will pop in the other. That way not everything is on one circuit. So yes, I am using the ethos from the world's worst fault finding video. I had to squeeze in that cover like this in Scarborough. But yeah, the donuts were good on the beach, so I can't mock that then. Right then, so let's get it on the test. We'll do the RCDs first. Why not? Let's mix it up today. So line, neutral, bang it on your earth, and then we'll test it and it'll come out with the results. We'll do this for all of them, and then we'll tell you the readings. Right then, so that's all the tests done. So this test actually tests half times at 30 milliamps, half times at 30 milliamps, one times, five times, and then obviously 0 of the cycle and 180 degree of the cycle. Tells you the tripping time then, and it tells you if it's passed or not. So it's a little bit slower than the fluke, to be fair, but to be fair, I ain't got my fluke out of my house because I was doing a bit of testing on that. I don't want 2 testers in my van, to be fair. You don't want one going missing or both going missing, do you? So yeah, everything's passed on that then. So this is what you do. So if it's a split load board, you're literally just doing 2 tests. You're doing RCD1, RCD2, if it's passed or failed. But unfortunately, not unfortunately, but on RCBOs, it just takes a lot longer to get all your RCD tests from 1 to 10, in this case. Right, so the lights are on in the house then. So what we're next going to do then is obviously knock the circuits off. We're going to pull the lines out and the neutrals out, and what we're going to do is just test between each conductor and figure out what's going where. So obviously we're going to test neutral to every other neutral. If it's linked, we're going to keep those, we're going to have that circuit on with the same circuit, if you get me. Obviously we don't want to have the terminal of the RCBO rammed, so we'll probably just we'll put one core in, a little fly lead to like a 5-way or something like that, just so you haven't got loads rammed in, which could cause loose connections or not tight connections, and then you've got fires, haven't you? So we'll prevent the fires. Oh. It's just going earth, which is connected to that earth. It's easier to put it on there because it don't fall off. But yeah, earth to line, we'll just test it. So we've got 1.8. I'm just going to go through them all and just make sure it's well over a meg, because that would indicate no earth leakage. 1.9. So yeah, we'll basically just bang through all these. If they're all clear, then we're going to test between then, and it'll be a borrowed neutral, which will be the issue. 1.7. Now I'm just going to do the neutrals then. It should be the same, to be fair, if the light is on. And there we go, so that's all the neutrals and lines passed then, so there's no issues there. So we can basically just test between the neutrals now and see if we've got any borrowed neutrals and the lines. The only caveat with that then, obviously with the lights on, when you power it off, obviously the lights are still connected through the switch, but if you've got something with a sensor, like a PIR sensor, obviously with the power off, the switch line cable is not connected, because they're always single pole generally. So you've got to bear that in mind, that the cable going from the sensor up to your light could be the issue. Right, it's flicked over to continuity. Let's go do this. Speed me up, Joshy. Beam me up, Scotty. Right, so we can safely say those two are going to be on their own then. So we'll just bob these guys over here, so they're safe to go on their own and with other cables that aren't linked to any other cables. There we go. Next. Alright then, so this is what we're left with then. So all them results, we basically tested between every core then. If we got a reading, a lot of these were twisted, and we got continuity between. So that one we got on, that one we did, that one. So this one over here then, we basically put it on insulation resistance. It's not just testing in from 0 to 2,000 ohms, it's testing from 100,000 ohms up to 1,000,000 ohms into if it's the insulation resistance test. And we got like 170 some meg on that neutral, and then this was like 0.05 or something. So we're going to bang those together because there could be a connection there, but all the rest of the cables, that won't connect to anything, that won't connect to anything, and this won't connect to anything. So it's either we've just not found the switch in the house and it just hasn't got a load on it. Could be like a light fitting that's not got lamps in. Could be something like that. That's why the reason neutral and line aren't connected. Trying to think what else. Oh, the circuit's been disconnected. There we go. So it could just go to a junction box. It's just been capped off because it is an old house. These are old wiring we're working on because everything's got extended in. But yeah, so what we're going to do then is we know all these are connected to each other, so we'll just bang them in one breaker. All the misfits, we'll just bang in another breaker, and then hopefully that'll be the lighting on without it tripping. So what we can do is obviously do one at a time, go around and see what it does. But the end result is, if everything's on, and we've got some cables left over. We don't want to disappear and then ring up going, oh, this light in this cupboard randomly that we didn't see is not working, then we have to come back. So obviously we'll just bang it all in and get everything powered up, and that'll be the lighting done, and we'll move on to this socket circuit that we're tripping out as well. Oh, down here. Yeah, you. Vargo, or Wago, has come out with a new 10-way lever connector. I'll show you. Look at that for a little advert. So have a look then. I'll show you it, and we'll need it because we've got quite a lot of cables we're going to put into one. Now look, a 5-hole lever connector. Or not, look at that base. The base is glued 2 back to back. You can have up to 10 cores in there, which is super handy. Then if like earth's in the back of the box, or this kind of scenario where you're going to have 50,000 cables and not enough ways. So obviously you need 4 and then 1 fly lead, don't you? And we're going to have more than that, so we're going to have to jump to the 10. There we go, that's that one done then. So we've got just a bit of cable from there to that connector block up there, and then all of them just shoot up the back. That's the best we're going to do then. So we're going to power this up, make sure none of these come live. They shouldn't, because it's greater than 200 on all of them, so they should not be connected. But you never know, some sensor might have some, like an extreme insulation resistance and it just hasn't picked it up. But yeah, we'll turn that on, see what turns on, go around the house, and then we'll come back. Now just to prove it then, so that is turned on. Let's see what's live then, see what's come on then. There we go, perfect example then. So this is why we turn it on and test it. I'll have to hold you in my mouth, hang on. Right, so those twisted together, we'll have to bang on with that circuit as well then. And one of the neutrals is live, the other neutral is slightly live, but you can see there. That's why we power it up and then got earth to these cables, because obviously it's getting its power through there and there, because whoever's wired this has done a bad job. So, I don't know. Let's get an absolute fatty of an upgrade there. So we'll take the 5-way go off. And there we go, and then we're going to put the 10 on, just because we need 1 extra spare way. Shame they don't do like a 6 or anything, but it is what it is. Not ideal, but what else do you do then? So that's all in the back of there now. Obviously we'll have to make these neater later, but all these then we'll bang in the other one and we'll see what turns on. So we'll bang this in here and then we'll go around the house. Yeah, I thought I'd just check it before we went round, and there we go. Live cables. Yeah, that's a bit better. In OCD we're not turn that one on. Let's see what comes live then. Get the sockets back on. Still got this to fault find, but see what lights come on. It's on the circuit with all good readings. That's with the hall on. Living room, bathroom, kitchen, utility. So the whole of downstairs is on at the moment. Right, these 2 lights up here are off. So bedroom, bathroom, cupboard, bedroom are off. Check the other side. On. Bedroom, bathroom, bedroom, all on. Great stuff. So it just looks like this end of the house is on the other cables, so I'll get those wired in next. So I also did the outside light, not the garage light. That's not on yet. Who knows? So now we'll do the other one. Oh, we're on. So that should have powered up everything else. But still no garage light. Let's just check the other side. There we go. It's on. Cupboard's on. Bedroom's on. Bedroom's on. Nice one. Everything's working then. Brilliant. That's the lights ticked off. So hope that's given you some ideas of how to do the fault finding and lighting. What do? Turn on all the lights. IR from line to earth to every, and neutral to earth to every cable. So if it's greater than 1 meg, it means you can now dive into the circuit then. You then do line to every neutral, then line. If there's a crossover, you connect them, you just twist them together, and then you go on to your next one. Obviously, you don't have to carry on doing. So let's say you got like 5, you got a test between. You can go 1 to 2, 1 to 3, 1 to 4, 1 to 5. Obviously, 1 to 5's already been. So now you do 2 to 3, 2 to 4, 2 to 5. So you got less tests to do, and it's 3 to 5, 3 to 4, and I did it backwards, and it's just 4 to 5, and that's all you test. You don't then need to do 5 to 1, you know what I mean? So that's it, you've basically tested everything. So it's not like a million tests, it's just a few. But yeah, it does take a while just to get through them all. Make sure your crocodile clips are fully clamped onto it, so you don't want it just half pressing, then you get a bad read and you connect it up and it trips, and you got to do the whole test again if you think about it, which is not ideal. But yeah, it's just the guards like that's not working, so bit of fault finding on that. So we'll open up the switch, see if there's power there for one thing. After that then we'll open up the light fitting and see if it's been wired wrong, or if there's a neutral there, or a line there, no neutral, something like that. We shall figure it out. We have light. That'll do. Hey, for some reason the neutral is disconnected. So onto the sockets. Go on then, what's the first thing we do then? So we've got lines into there, neutrals into there. We can test the circuit. So let's just whip that out. Some sockets are off now, we don't know what they do. We'll leave the other socket circuit on so we know what we're looking into. Right, so if you remember literally from about 5 seconds ago, we are doing, have a look, a what? Insulation resistance test. So we don't have to turn anything on, everything's still plugged in. So the test results we're getting now are the things plugged in, which could be the issue. It's the cable, or it's the breaker. The breaker is an MCB, and we do put an RCBO in, we'll have to test the RCBO. Yeah, let's get a test then. Insulation resistance, and we'll test line to earth, neutral to earth, neutral to earth, and we'll see what we get. But before all that, kids, we're going to do an end to end, because it's a ring, there's 2 cables here. So we do that just so we do one test. So if it's a ring and it goes from one, basically from the fuse board all the way around the sockets and back, you'll have live earth neutral this side, live earth neutral this side. If there's a break and you only tested one side and you don't do the other core, then you'll be getting false readings, won't you? So continuity, line to line, 0.67. So this neutral, we should be getting similar, should be getting around 0.67 again. So that's clipped on. 0.68, so anything within 0.05 of each other is acceptable. What circuit's that to? So this guy's done it right. It should be, no, it should be this one actually. Right, so undo this. I'll get end to end on this. Pin up then, what I like to do is get it on them little teeth there. Let's have a look there, so those teeth here. If you get it in here or those, it barely nips it. So you want a really good clamp on there. Anyway, 1.46, which is about right. So now when we're doing the earths to line, again, they're disconnected now. I'm going to pop them back in just in case it's like line to, like one of the sockets is connected to, I don't know, some pipe work or something, or another circuit. If I just tested the circuit, it wouldn't actually tell me a full story if that line is connected to that earth or that neutral is connected to that earth. Would it now? Now we're going to do earth to line, earth to neutral on insulation resistance. So I'm clamping on right now, I'm pressing test. 0.060, so anything less than 1 failed. So obviously the neutral, because it'll go through some sort of appliances. And there we go, should get roughly the same reading. So we don't have to test the other core because it's a ring, we've just tested that. And that's important for the steps we're about to do later. So if it is a ring, it means we can basically chop that ring in half, and then when we're testing round, when we test between earth and neutral or earth and line, we'll get a good reading from one side and a bad reading going back the other way. So that's really helpful for fault finding. So you split the circuit. If it's good, you ignore it. If it's bad, you don't. So make sure these sockets are on. Apart from everything's on apart from that one circuit. So what we're going to do now is dive into the circuit and see what sockets it's actually doing. So it could be doing kitchen sockets, could be doing all sorts of sockets. I can't find my socket tester. Alright, so now I'm just going to bob around the house then, plug the socket tester in. That's its downstairs sockets at the moment, so that's one we'll have to look into. We're going to plug in everywhere. If it's live, we're going to ignore it because it's not part of the circuit that we're looking to fault find on. At the same time, I'm going to unplug anything you can see. Oh, knocking over books. There we go. So go around, test it dead, unplug it, but halfway through unplugging stuff, we're then going to test it again. Imagine unplugging 20 items, 30 items or something, and then you go back and it clears. It could be any of those 30 and you've got to do it again. We're going to do it half, test. If it's still bad, we'll carry on unplugging things. Why do we unplug things, you might be asking, James? It's because all that does is disconnect the line. It doesn't actually disconnect the neutral and earth. So, what is that light fitting doing? And it gets better, this, look. Alright, so the old conservatory at back. We can ignore that. This room. So at the moment it's just kitchen, this room. So we're gonna go upstairs. I didn't actually check this one. Oh, it is this one. Right, so it's this we need to look into. It will be something like the underfloor heating system. So if they don't use it, or they've said it stopped working, could be a neutral earth fault on that, couldn't it? So they'd have to get into the controller, disconnect the neutral out of that and the line. So that could be a possibility, because everything else is just cabling. It's very rare for the cabling to go. It's normally something like an appliance, some dodgy oven or fridge or something. Back up we go. Right then, let's test this again then, see what we get. 0.06, the fault is still there, so I'm just going to bob upstairs now. So everything we've unplugged is probably good readings, to be fair, so we can ignore those. Right, so just eliminating rooms then. So that is still live, that's still live. This one isn't live, but this one is live. Let's just check that. Yep, so that's one half of the house. It's just one bedroom to look at. Kitchen, front room, back room. We've got two living rooms, or dining room if you want to call it. Still live, so this end of the extension is okay. Now let's check these two rooms then. I think I will dive into that underfloor heating if this is not cleared. Hope I don't find it. Yeah, but ignore this one. Right, so just to recap, we got this socket there, a couple in here, all the appliances. I haven't checked this side actually, I didn't check this one. So that's still on, but these are not, these are off at the moment. So it's one side of the kitchen, dining room with underfloor heating, those two sockets. Come on, what do you think it'll be? That socket there. So I'll have to check with this power for these appliances, knock them off, and then check the underfloor heating, I think. So I'll do a test now I've unplugged a few extra things. We'll dive into this little baby. Oh, we've found something. Let's move this little wicker basket out. Look at that. And I see these, they've got a tendency to tie neutral and earth together. And I've had that, like an outside RCD socket, cause it to trip before. So I'm going to disconnect that and hopefully that'll be it. Right, let's leave that like that. Right, let's get that tested then. Hopefully we found it right. I haven't pressed test yet. This is the moment of truth. No! How we're going to do a full scope at house then. I'm going to go in and well, the ring's split now, and we've disconnected the RCD fuse spare. I thought, right, it's split, so we can just go around and test everywhere. We'll have good side, bad side. However, before we do that, look at this. Time guard. I thought, let's do a scope of the property, see if there's any outside sockets. Look at this. RCD socket. There we go. 0.102. So you tested the line on that. I've taken the conductors out. Just so we're literally just testing the socket. Oh, I need 3 amps. Right, ready, just to prove. Oh. There we go, 0.10, and then I'm just going to test earth to this little fella. Greater than 200. Oh, this is great. There we go, and to neutral, 1 mega ohm. Hopefully, that's it. So what we'll do is just disconnect this off. We can't swap it out, we'll have to swap the full socket if they want to keep it. So we'll just cap it off for now, put it all back together. Put everything back together, including that fuse spare on my belly. And hopefully the sockets will come on and not trip. Or at least we'll have greater than 1 meg, which is what we want. Oh, that was painful. Squeezing under there, trying to do that fuse spare. Oh my goodness. Yeah, I've swapped it back to a fuse spare now, not an RCD one. Just in case this starts playing up. It don't need to be RCD protected, because it's got RCD protection now, so. Right, we'll do one last test. We'll get an RCBO on it, and then we're done. Yeah, let's get a test there. 1 meg, that'll do. So it was 0.06 before, so there's just still some other bits on that circuit. Oh, it's the cable in itself. It's over 1 meg, so it will not trip. Yeah, I've never seen a musical kettle before. Schmeg. Then that's a wrap then. So we've got the power back on, we've got the RCB or installed for the sockets. It's not tripping and the customer is happy, they've got power. So yeah, the lighting then, we managed to split those across 2 different circuits instead of it all being on one. There were a few shared neutrals there. The sockets then, the issue was the outside socket. But yeah, hopefully this gives you an idea of how we fault find and fix issues, because some electricians go to jobs and they'll be there for days and never find it. But generally we can fault find within the hour and figure out what's going on. But this one took an hour of fault for this one. So it took us a good hour messing about with those lighting cables and then an hour for the sockets. So we haven't done too bad there, have we? So hopefully you enjoy this kind of content. If you have, then hit the like button, hit subscribe, hit the little bell notification so you know when we next upload. So as always, have a good one from me, and we'll see you on the next one.